Hello guys, welcome back to my YouTube channel. Let's solve today's POTD. So today's POTD is very simple. You are given an array and we have to find the largest pair sum in array of distinct integers. So one good thing is integers are distinct, like no two integers are same. Like here you can see 12, 32, 34, 10, 6, 40 all are different. And you have to find the make largest pair sum. Pair sum means you have to select two integers such that their sum is maximum. So this is the question and we are given array and expected time constant is order n. So let's understand the question first. I think all of you have understood the question. So you have to find the largest sum. So when we will get the largest sum, if we select the largest two elements, suppose these are the element and these two are largest, then their sum will also be the largest. So ultimately you have to find the two maximum integers that are present in array, because suppose 1, 2, 5, 3 and 2. Here if you 4, okay, no, they are distinct. So if here you see what will the maximum is, select maximum 2, 5 and 4, these two are maximum, the sum will be 5 and 4, 9. Here you see 12, 34, 10, 60, 40, the maximum is one is 40 and one is 34, sum is 74. If you select the largest two, then their sum will be the largest person then that you can get. So now the question is, you have to find the largest two, not the largest one. If you have to find the largest one means the maximum one, then you can easily find. But here the one, like, modification in the question you can say, or modification in the algorithm, that you have to find the maximum two. Okay, so one easy solution is you can use the sorting algorithm, and then after sorting it will become something like this: 10, 6, 10, 12, 34 and 40. After sorting, this will be the maximum. So after sorting, you take this last two elements and they make their sum. Then this is the correct solution and this approach is also good. But the complexity will be order n log n, because you are doing sorting here. But we want to solve this in order n, because expected time complexity is order n, obviously, because everyone can solve this using sorting in order n log n. Okay, so now let's come to the solution, how you can solve this in order n log n. Okay, so here, 6, 14, 10, 34 and 14, this is the order. So you have to find the maximum one and two maximum element na. So suppose this is the max one and this is the max two. This is the highest and second highest or largest, you can say anything, and this is the second highest. Okay, like this is the maximum or overall maximum, and this is the just below maximum. Like here it will be, this will be 40 and this will be 34. Okay, maximum and second maximum. Okay, so now what I will do, just think clearly. Like I initialize it with max one, initialize it with both. I initialize it with -1 in n, because minus you can do it with -1, 0 and -1 also, because all elements are positive. But I, for the safety purposes, like I generally use this 1 in n, means like these are most least possible values, okay, of integer. So that's why I initialize it max 1 with and max 2 with this same. So now if I get this 6, I know if now I get this 6, so I can say max, these max 1 and max 2 are different, it cannot be the same. Okay, so max 1 will be, now we have this 6, so max 1, so now max 1 will be 6 and max 2 will be, still it will be -1 in n, because there is only one element. So we can assign this 6 to only one, and we know this max 1 and From here we can also say that like it can be equal, but in our case it is given elements are distinct, so this won't be case, but in general it can happen. Okay, so now after this 6 came, this max 1 becomes 6 and max 2 is still 29. When this 14 came, what we can say, max 1 will be now 14 or not, because the maximum possible is 14 and max 2 will be 6. Now when this 10 came, max 1 is still 4, max 1 is 14 and now this 10 came, so it will be still 14, it will not change, because highest possible is max 1 will be 14. Now you check, you see max 2 will be changed here, because now max 2 is 6, but if we modify it to 10, it will become this. Now this 34 came, we see here max 1 is less than this 34, so we update this. Like we can update only if current value is higher than max 1, we will update max 1. If current value is higher than max 2, then we will update max 2. Okay, now see here this 34 came. Now if 34 came, we can update it with 34. Now one observation is, like, now we updated this max 1 to this new value, but the old max 1 can be used as a max 2 now, right? Because the old max 1 was greater than this max 2, like max 2 was 10, but now this max 1 has value 34, so now this max 2 can have value 14 or not, because now max 2 is not in use by max 1, so we can use in this max 2 this way. Now this 40 came, again the same thing. 40 came, 40 is greater than 34, so max 1 will have 40. And now we can see now 34 is not in use, so we can do, like, we can update this max 2 with old max 1, so max 1 will be 34. Now we have nothing to do, so these are the max 2 and max 1, this is nothing but 74. Okay, this is a simple thing. So we, if in like logic wise, if you say, so if, okay, let me write simple for auto I arr, if I is greater than max 1, greater than not equal, if I is greater than max 1, what we will do, we will just update the max 1 with I. Okay or not, because this I is greater than max 1, so we will update. Or what we will do, we will update the max 2 with old max 1, because this was highest before this. Before this I came, max 1 was highest, right? Before this I came, max 1 was highest. Now this I came and I is better than max 1, so we will update this. And now, okay, I have to write this is come here. You are getting why? Because if I will write here, then it will be I, it will be I, this will be I, this will be I. So think carefully. Step will come here. Okay, because if I write this step earlier, this max one become here, max one become I, and then next two will also become I. So that's why now suppose this is your max 1 is higher, this is your max 2 is lower. Now we get I here, because I is greater than max 1, I get here. So what we can say, initially these and these were the maximum 2. Now this came that is greater than max 1, so we can say these and these are the maximum now. So the max 2 will be the max 2 will be old max 1 and max 1 will be the I. Okay, this condition. Also, if this is not the condition and this is the condition, if I is greater, if I is greater than max 2, if I is, if suppose like this, max 1, max 2 and I is something around here, because I not greater than max 1, I is somewhere here. So max 1 will be same, so we can max 1 will be the same, and we can update this max 2 by I. So we will update this max 2 by I. Okay, these are the two possible cases. Like, suppose you can understand like this way, this is the good thing I have found now. This is max 2 and this is max 1. Okay, so there are total possible case. This is the first case. If I is here, then what we will do, I is greater than max 1, then we have to shift this. This will be the new max 2, and this will be the new max 1. So now this is the new max 1, and this is the new max 2. Okay, what is the new max 2? New max 2 is nothing but the max 1. New max 2 is nothing but max 1, and the next one is nothing but I. Okay, you have to make this step like this only, otherwise you will. Now you understand, like if you update this max one first, then max one is I, then we are doing this. If you do step this later, then both will become I. So do this update to first, and otherwise you can also store in some temp variable and then use. So this is the first case. If we get I somewhere here, we can see that mx1 will not change because this is the highest element is still same, but we can update the max2 because second highest is here now because you got I. So that if this is the case, update the second highest, that is nothing but max2. And if you get got I here, then you don't have to update anything because max1 is higher than that and max2 is higher than that. So no need to update anything. This way you can do this. So now come to the coding part. Coding part I have also explained this is the same thing. Like this is the initialize with minus 29 minus 29. If I is greater than max 1, then update max 2 first and then max 2 1. Like now the max 2 will be the old max 1 and the max 1 will become I. Okay. Or if I is greater than or equal case is like if I is equal max 2, then it will same. Okay. So if I is greater than max 2, then max 2 will be the I. This is the second case I have explained here. If I is here, then I will I is here, then I will update this max 2. Okay. So this is the thing. After doing the iteration, you will find that you have found the max 1 and max 2, then you just return the sum of the max 1 and max 2. This will be the solution. Okay. For time complexity, if you talk about, then we are looping over the we are looping over the array once, then time proxy is always order n only, and we are not doing any kind of sorting something, and you are not even using map, etc., etc. Don't no need to think about anything. That's why simple order n time complexity. And you talk about space complexity, then we only declared two variable and nothing more than that. So space complexity also one. So this is the best possible solution, and this is the expected also. So the solution is correct. Let me compile it for you. I have compiled it, but I'm also compiling it for just for you. So here you can see our answer is correct. You just see the Litecoin coin. Okay, so this here you said two times. So this is passed. Thank you very much. Please subscribe my channel, and I will upload solutions daily. So please subscribe to my channel and like the video. Thank you. Bye.